Going through my mind the whole time. The best way to describe what happened next. There you go. Oh, yeah, that's correct. We're talking about D&D. What? So did you like? Yeah, I did that.
All those germs out. How's everybody? Good today. Looks like a bunch of little bandits coming in. Now that it's getting winter and everybody's got hats on, really only seeing your eye. Just a little bit. We got done with that Unit 2 exam and I haven't even looked at it to see how everybody did. So I will do that and we'll talk about it next time. We've got everybody here. Great day. We're going to start talking about repetition today. And usually when I think about repetition, I'm, how when we looked at if statements, I was trying to make you guys stand up depending on what row you're on and everything. Because when you move and you get up and you do things, you remember things better. I was trying to think of, what could we do to stimulate repetition? Well, we could play musical chairs. Probably not the best COVID activity, right? Have you ever played musical chairs? I played it when I was a kid, and there was a few times it would get pretty competitive. I was always real small, so I was always that person that would go flying across the room. I would be in a chair and then out of a chair. Yeah, it was a really violent game, kind of like dodgeball. They always have all those arguments about should we play bombo or not. I can say, no, we shouldn't. I would always get hit by like 8 balls all at once from all the really good boys that were good at throwing things. So musical chairs. If we were going to play this musical chairs game at a party, would we have to do anything to get ready for it? What kind of things would we have to do? Set up our chairs. We have to find some music, all those kinds of things. But the chairs are a really important thing, right? So what kind of rule would we have to have about our chairs before we set it up?
Your amount.
The amount. And what would our amount of chairs have to be?
Number of people.
One less, exactly. So if we didn't initialize or properly set up our number of chairs, the game would be kind of worthless, right? Because we've got to initialize properly and set up our chair number. And then whenever we start, we would explain it to all the people playing. We're going to start music and you're going to walk around nicely without running over people while the music's playing. And then when the music stops, you're going to find a chair. So our repeat condition, how long we wanted the people to walk around the chairs, would be a state kind of thing, right? As long as the music is playing, I want you to keep walking around the chairs. So we're not asking anybody anything. We're not saying, hey, are you done walking around chairs yet? No, we're gonna run this loop until a certain state or condition is met. And that's gonna be we quit playing the music. And then when we quit playing the music, everybody's gonna sit down. Now, each time we quit playing the music, we have to update. What do we have to update?
The amount of chairs.
How many chairs we have, right? We got to get rid of one. And then we can start that repetition again, letting them walk around the chairs while the music's playing. When are we going to finally be done? There's only one person. That last person sits in that last chair. We're going to know that we're done. And what's really cool is those are the exact same things we have to do to handle a repetition, a loop in our programming language. We have to initialize, get everything set up before we start. We have to determine what the condition is. How long are we going to keep this repetition going? And then we have to update something for every iteration or every time we execute our loop. So just like playing musical chairs, we've got to make sure all of those same things happen in our program. So let's talk about doing that for real. Let me admit these poor people. And share my screen with my beautiful musical chairs knowledge. Can tell a big heavy duty presentation on that. Okay, so what I do have a presentation about, though, is how we can set up our repetition. So in week 9, which is where we are, we're past halfway. There are two PowerPoints. One is the textbook one, and then the other one is the one of mine. And I think the one on top is the one of mine that we're going to look at today. Yep. I'm going to download it. So it looks just like the beginning of the presentation from the last chapter. It's like a duplicate because a loop is run the same exact way as an if statement based on a condition, right? So just like an if statement, my condition is what matters, decides what code I'm going to execute. Am I going to execute the code on the true path, or am I going to execute the code on the false path? Same thing is true with a loop. I'm going to have some sort of condition that determines how this repetition is going to occur. So we can put a loop in a flowchart in a lot of different ways. There's not a real good consensus on this. You might come up with a better way yourself. But what's going to happen is in a flowchart, we're going to have an arrow that probably points backwards. And it's going to point backwards to some sort of decision structure. And that indicates that we're going to loop. We're going to continue looking at that decision structure until we get a different response. So let's look at this flowchart. Here we're starting. We're saying we're going to get some data and we're going to do a decision. If our decision results in a false condition, we're going to execute some sort of process. This would be our loop body, right? The thing we're going to execute in our loop. When we get done executing that process, we're going to come back and check that condition again. If it's still false, we're going to execute our process again. And we're just going to keep looping until something that happens within this process changes our decision. And now, instead of getting a no response, we get a yes response, which gets us out of our loop, ends our loop condition. So we don't have that going on anymore. So whenever we're looking at flowcharts, a loop is usually going to have some sort of decision diamond with an arrow that's pointing backwards to it. So that's why our arrowheads are so important in our flowcharts. Now our test condition, just like with an if statement, we're going to create a condition that results in a true or false value. We're going to use our relational operators, less than or equal to, greater than or equal to, is equal to or is not equal to. Our condition, just like an if statement, has to have both sides, the right operand and the left operand. Is A equal B? Is A greater than B? Both of those things can be variables, they can be literals, just the same things they could be in an if statement. But we do add a few terms when we're talking about repetition or looping. The first term is iteration. Now, the first time I heard that term, I was in college, and I can remember it. You know how sometimes you just remember those terrible things that happened to you? Because I was sitting in this Fortran class. And what is Fortran? An awful, obsolete programming language that they actually still use in terrible places like meteorology and things like that. But I was in this class, and it was an engineering class, and I was a computer information systems major. And so it was the only time I veered over into that engineering department to take the class. You know, the first day of class, that guy assigned chapters 1 through 12. What should I have done? You know it. Did I drop it? No, I didn't. I stayed in it, and it was really tough. And he did expect us to have all 12 of those chapters read by the second time we had class. And it was a crazy intense class. But he said, like about 2 weeks into it, he was just talking all these crazy math engineering terms that I'd never heard before. And he was like, how many iterations did your loop perform? And I was like, I don't know, what's the iteration? And then I found out it's just a time that you execute your loop. So every time my tires go around on my car, that's an iteration, and it's nothing fancy or super engineering. And you guys all know that because it's a common term nowadays, but back then it wasn't. Now, the loop body is the code that will execute if my loop condition is true. An infinite loop will make some of these. Some of these you will make by accident. We'll do a couple on purpose so that you know it can happen. An infinite loop is a loop that never ends. I don't update the condition in my body, so my loop can never end. This is like playing musical chairs and never taking away a chair. It just goes on and on forever. And then some other things about loops, we have different types of loops. So there's some additional terms there when we talk about the different types. One type of loop that we have is a pretest loop. And in this kind of loop, we are checking our condition and we are only executing our loop body if the condition is true. So before I ever start my loop, I'm going to make sure that my condition is true. Here's an example of a flow chart. We start, we input a number. Is the number valid? If no, we're just going to ask them to input a number again. And we're just going to keep stuck in that loop until they finally type in a good number. And we'll do that today. It's some example code so that we can make sure our user types in valid input. So notice in this example, we didn't check to see, well, the way the flow chart is going, we're checking to make sure it's valid input before we ask them again. We could do that loop either way, as a pre-test or a post-test, but in this example, it's a pre-test. So here's an example of some pseudocode of that. We write out this message, please enter a number, and then we input the number. At that point, we're going to go into what's called a while loop. And the while loop has this syntax that starts with the keyword while, and that has a condition. So our condition is just like a condition would be in an if statement. It's just instead of the keyword if, we have the keyword while. Now, whenever we do that, everything, all of the code that is in our loop body between our while and our end while is going to keep executing over and over as long as that condition is true. So our while condition here is, while our number is not valid, we're going to ask them to type it in again. If it finally is valid, we'll drop out of our loop and continue on executing our code after that end while. Now, a post-test loop is a loop where we don't check the condition the first time through. So in this example, it kind of works a little better for our input a number scenario here, or at least it looks like it does from our flowchart. We start, we input a number. Is our input valid? No. Input a number again. And we just keep asking for it. So in our flowchart, notice it's not really a lot different. But in our code, we can kind of tell the difference a little more. If we're using a bottom controlled loop, we're going to use syntax like repeat until or do while. And I'm going to give you some different examples of these different kinds of code syntax, because different programming languages do it a little bit different. But in this case, we're saying repeat these two lines of code until our number equals valid. So it's not a lot different. It's just that instead of having our condition before our loop code, we have it after. So in this case, this is going to happen, this loop body is going to happen at least one time. Whereas in our previous case, our loop body would not happen that first time if our number was already valid. Now here's the do while. So notice how it looks just like the repeat until. It's just that we have different keywords. So this can be really confusing to people. So I guess the thing is, look at the code and see if you can read it. And then after you've decided if you can read it, worry about the actual keywords. Because looping syntax, there are so many different ways that we can see it done. And all of them make sense if we just look at the code. We say, oh, okay, I see what this is doing. It's just a little bit different. Now, just like if statements, we can nest our loops. So in this loop is someone trying to park. And I don't think you guys have had too much trouble parking this semester. Sometimes it can be crazy. And once they start building that building over there, it might get bad again because I think they're going to tear up some parking lots. But here's a loop within a loop. In this loop, we have a state thing. We say our state is we're trying to park. So while we're trying to park, we're going to go into a sub loop to check this parking lot here for Norman K. Myers. While we're in that loop, if we find a spot, we're going to set our trying to park and our checking NKM variables both to false. That should end both of those loops. But if we're still looking, we're just going to keep driving. So notice how within this inner while, I could do something to update some sort of variable that ends that loop and ends the outer loop. So we can do our looping syntax however we want, but we can definitely have loops within other loops. So let's try some stuff. If you'll go to our modules, on the week 9 assignment, this one that has our colab document, colab IPython notebook, all it is in your assignment is a link to this collaboratory notebook. So go ahead and let's open that. And then I want you to do File, Save a Copy in Drive, and then this name is fine, copy of, or you can rename it however you want. One thing I've noticed when you guys are submitting from your Google Drive, if we keep the .ipynd on there, it works better for me. And what that stands for is IPython notebook. So that's what we're using here in Collaboratory. It's called an IPython notebook. And IPython notebooks are actually replaced already by Jupyter notebooks. So if you're seeing some sort of comments talking about like things like that as you're looking for any information on our collaboratory notebooks, that's why, that's what it's based on. Okay, so I tried to make a pretty one. Let's see what we've got here. Over on the side, if you open up your table of contents, you should see it kind of created a collab document that includes all of the pseudocode from our Prelude to Programming book. So if we start at the introduction here, I wanted some sort of color, so I put colored-y things in there. They're not important. They're just separators. But in the beginning, I have some basic notes for you. And of course, you could add to these however you want. But basically, we have two execution modes, pre-test and post-test. Those are the two we were just talking about. Test the condition before the loop body, test the condition after the loop body. Now, as we go through our collab document here, we're going to be talking about some of these different categories of loops. I can have a loop that's controlled by a counter, by a sentinel, which we'll talk about, or by the state. And we've already talked about a couple that were state controlled. And then below that, I have some loop syntax. We could see do while, do until, repeat until, while, for. So we have lots of different syntaxes for loops. So my advice here is, again, don't get scared away by the fact that there's different syntaxes. They're all going to work very similar to each other, and all you have to do is look at them to figure out what's going on. So it won't be the end of the world. All right, the first section of our textbook then talks about repetition structures, and they give us some pseudocode. So example 5.1 gives us some pseudocode, and it says simply writing numbers. Everybody take a look at that pseudocode and think about what it does. How is that going to ever end? What do you think? Will it never ever end? If they enter a 0, that should make it stop. So we didn't tell them that. It's always nice to tell people things like that when you're writing a program. So do add things like that in your write statement. Please enter a number 0 to end, maybe. Now we can see what's going on here. We're just going into this loop, and we're asking the user for a number, and every time we read a number, we just print it out. And then when they finally type in 0, we're done. Look good? So this is a bottom controlled loop. Is that correct? Bottom controlled loops, Python hates. So we'll just look at those. What about this next one? How many iterations? Take a look at it. What is it doing? Not much different, is it? What's it asking for instead of a number? A sibling here. And again, we just read in the name that they type and write it out. And in this one, we're asking for the word done to end it. Again, we didn't tell anybody that, but that's what we're looking for. Now, when we're looking for a word like that to end our loop, sorry, I was looking through stuff. They call that a sentinel. And a sentinel, what that word means, a sentinel is like the guard at the castle gate. And so the sentinel is going to keep people out of the castle or keep allowing people in. And in the same way, a sentinel is just the value we're looking for to stop the execution of our loop. So it's like the guard of our loop. So that's the sentinel value that we're looking for. Now in this particular one, we're just repeating and printing out names as long as they give them to us. Now here's an infinite loop. Take a look at it. We start out with a number and a computer number. And in our loop, we're saying, please enter a number. And whatever they type, we're reading in as number. Then we're setting the computer number to the number they put in plus 1. And then we're writing out the number. Now, at that point, the first time through, if the user types 1, number is equal to 1 and computer number is equal to 2. So our until condition is not going to be satisfied. So we're going to keep executing. And nothing is ever going to make that until condition get met. So we're going to keep executing forever and ever. Now, this kind of infinite loop that we're looking at here, this loop is dependent on the user. So it has, what do we want to call it? It has a break, right? Because it stops using the processor and it asks for input, and we give it input. So this loop is an IO loop. It's going to keep asking for input and then it will output that information over and over. An I/O loop is bad, but it's not as bad as a CPU loop. A CPU-bound loop would be a loop where we never input or output any information, just do some sort of calculation or something over and over. Think about that loop. It's got a hold of the processor, and it's just going to keep a hold of it until something else can cancel it or end it. You guys have all seen loops like that. Those are the kind where you're trying to alt control delete and get to task manager to end task. You're having a hard time even doing that because it's processor bound. So a CPU bound loop is much worse than an IO bound infinite loop. Neither one of them are good. Okay, so I'm going to continue on. All of these pretest loops are things that are hard for us to replicate in Python because Python does not like the pretest loops. So example 5.4 is basically that first one that we had, only they made it a little better. This time in their pseudocode, they actually do say enter 0 to quit, and they output things, and at the very end, they write list ended. So here's our first activity. We need a flow chart of this. So I'd like for you to create a flow chart using your FA20 drawing tool. I'll try to fix that typo, but you've already copied it, so you're going to have to fix it yourself. How can you fix it, you ask? Oh, good question. Click there, and in this little toolbar, click the Edit tool. When you click the Edit tool, you're in what's considered Markdown editing mode. This text that's in our colab document is a Markdown document. And so certain characters mean things to it, like the hashtags. The hashtags say, make this thing an item in the table of contents over here. All right. So anyways, I can mess with that stuff that's typed in there, but I just want to fix this typo, favorite. And now that I've got it fixed, I can click this close markdown editor icon that was my edit, and it'll close it back down. You don't have to fix it, but just because it's a terrible typo. So we need a flowchart of this thing. Using your favorite drawing tool, use the snipping tool to create an image of the flowchart. So for each group, I'd like for you to make a flowchart of this process. I'm going to set my alarm to about 15 minutes. Now, what you could use to do this, you could use Raptor, maybe. You should be able to, but we haven't done any looping with Raptor. If you want to just do a simple flowchart, you could actually use any sort of drawing tool. There are some really great ones. We have Visio on these computers. You could use it, or you could use create.ly, creately.com. You could use Word. You could use PowerPoint. So any tool like that that you want. The other thing that you could use is you could almost use a piece of paper and a pencil, and you could draw it and take a picture of it. So I'm starting to think that's the best way to do flowcharts. I'm going to leave it. Okay, so I'm going to set my timer for 15 minutes, and we're going to see what everybody's got.
Because it wasn't, it's number. So maybe we need to set the input right there. We put it down here. So, enter local condition, that would be. So we need to put this right here. Oh, I had to close it off, that's why. Okay, so now we don't need that now, so we can just shoot this. No, I guess.
I wish there was a better way. I keep spending way too much of my life trying to like
December 0.
Sorry, I do it one day at a time.
I'm sorry.
Yeah.
That's what the note is.
I can email it to you.
I see how you are. I make you start to complain if I don't let you do it. I think that was good.
I'm still.
Yeah.
There's not, whenever, we're gonna have to delete it.
Yeah, so that's. Roger will force you to do that.
Now,
You did it this way, it makes you just condition.
Yeah.
Oh, we have a lot of really nice graphics.
Exactly.
But we gotta get
That's true. You know, there's actually canon. Oh, that's just a word. Brother, sister, and it's so now they're going to I just like, I looked at it.
the extra was put it out. Yeah.
Okay.
Yeah, look. Oh, you put it
Oh, yeah, same.
You got it. Just put it.
Oh, from,
Oh, yeah. Oh, it works. Like, what? It works. We're just looking at what you say. Scroll the top. You can see it.
Look at it.
You're right. What do you think you're doing?
Student activity.
It didn't like when I put you in. Hey, it wasn't.
Okay, beautiful flow charts. Stop it. So I'd like to get this into my colab document. And a lot of you did Raptor flowcharts, which is awesome because you can make sure they're correct, right? I didn't, I used Visio. So Visio, remember, is available to you free through that Microsoft program. But I used Visio and I just drew it. So I want to get it into my colab document for the grade because I'm going to have you guys turn this in. So I'm going to use the snipping tool. And there's lots of other things we could do, but in my snipping tool, I'm just going to grab this. And then in my collab document, can I paste? Yes. And it pastes all this junk is your image. So now when you click the icon to close the markdown editor, you should see your image. So it does look like it's a bunch of gibberish because it's got all the image code in there. Now, if you notice on mine, I did put a title, a heading, because this document is kind of big and we're going to turn in multiple things. This will be your only flow chart though. So if everybody's got a flow chart that they are comfortable with, let's go do some Python code. Great job with your flow charts. All the ones I looked like flow charts and looked correct. So for example, 5.5, we got the brother and sister thing here, and we want to enter the word done to quit. So let's do this in Python. Right under the student activity heading, you should see a code section already in there. And of course, you could click on that plus code if it was gone and you needed to add one. But I want to do this first one with you. So let's try it together. We're going to start out with a comment block. And we'll say this one is sibling list. And we're going to say our purpose is just to create a list of siblings. I'm going to end my comment block. And when I scroll up and look at that pseudocode again, they say they want to use this variable name. And in Python, I like my variables, of course, to have those lowercase names. So I am going to make that a lowercase n, but I'm going to set it to begin as an empty string. So Python will know and decide that that's a string variable because we have the two double quotes. Now we're going to do our prompts here. And in our prompts or our input statement, we actually have 2 lines of messages. So you guys know there's a bunch of different ways we could do that, right? We could say print this, then input the name, or we can just do it all in one statement. Let's do it all in one statement today. So we want to get a name variable, and we want to get it from an input statement. Now our input prompt is going to be 2 lines long. So I'm going to start with that first line. We want it to say, enter the name of your brother or sister. Now after that, I want to go to a new line. So I'm going to do the \n. And then I'm going to continue with the prompt. Enter the word done to quit. Now, I noticed that they had a colon after the enter the name of your brother or sister, and that's not going to work because I was on the first line. And we could say enter the word done to quit and put a colon there, ready for the user to enter data. So let's try it. I'm going to close this table of contents so you can see that whole line of code a little better. And I'm just going to run this thing. I don't have too much code in here yet, but I want to make sure that input prompt looks right. So here it says, enter the name of your brother or sister, enter the word done to quit. It looks okay. Look all right? So I'll just click and enter or something to get it out of execution mode. So I like that. So now we can go into our loop. And in our loop, we're just saying while the name is not that message done. So in Python, we do have a while loop, and its keyword is while. So we can say while, and we can say while the name is not equal to done. Can we do not equal that way in Python? Let's check it. Python not equal. So easy for us to check. And here's a little example. Yep, exclamation point equal should be not equal. Sometimes it's just nice to check. Okay, so we're saying our condition is we want that variable name to not be equal to the word done. Now, just like an if statement, we're going to end that while statement with a colon because it has a body. Now, when we press enter, we should be indented. And what do we want to do? We want to do that same exact input statement again. So I'm going to copy the whole thing. And I want to copy the selection, not the cell. So remember, the cell is our whole code block here. So just the selection, and then I can Control V to paste. Now, because we managed to put all of our prompting and our input statement all on one line of code, I think that one line of code is our whole loop. So now we can outdent and we can print something. It's not in our pseudocode, but just to give us that nice feeling, we'll print end of list just so that we know we are at the end of our loop. And that way, if we do accidentally leave that line indented, it'll print every time and we'll know it's part of our loop. All right, let's run it. Okay, enter the name of your brother or sister. I'll do another one. It seems like something's missing. What's missing? We didn't print it. Let's stop executing and we can click our play button because it's kind of like a pause or an interrupt to make it stop. And we can put in what we're missing. So for each time in our while loop, we should print that name and then ask for another one. Now notice our order here of our code. We asked for one before our loop started. So the first thing we have to do inside our loop is print, then ask for another one. Print, ask for another one, print, ask for another one. So in order to get ourselves initialized to set up our loop, we asked for the first one. Now let's try it again. This should look better. We should see those names getting printed out. There's Robin. And my next one. There we go. You can tell my parents were those types. They wanted us all to have the R names. You guys have that? My sister Randy's always been mad about it her whole life because she says they gave her a boy name to keep it an R name. I've seen other people's families that did that had many more children. They start reusing names. Bob 1 and Bob 2. Everybody's work? Got a loop? Let's update our Python quick reference. We haven't updated it in a while. And it might be something that you want to convert to a colab document, but yet it's so nice to just have it in Word. Let me get mine open. It's been so long since we've updated it, it's not in my recent documents. I don't know about you guys, but I'm getting too many places here. So what do we want to add? I'm going to put this at the end. I want to add something about while. So while A equals B. Now I'm going to fix that because I've got that highlighting. I'll fight with my highlighting later. It's very mad at me. So over here in our description, let's just say repeat the body of the while statement until the condition becomes false. So those of you that use Raptor, you saw that with Raptor, you might have to change the condition that you're working with to get it to work right. There we go, I had it somehow painted. So in general, when we're working with a while statement though, we're gonna keep repeating this while it's true. So the while is logical. While this is true, keep doing this. If we were looking at syntax that had like an until condition, then we would keep repeating until it were true. So we would look at that syntax to help us know what's going to happen there. So in my while clause, that's it. That's all. There's no other syntax. There's no other conditions or anything that we can use. Well, that's sort of not true. With Python, there is an else with a while clause. The else will execute if the while condition is never true or something like that, but it's kind of unusual. So you can do it, but I would recommend you not do it because it's not something that would be usable in any other language, but you can. So our while statement, easy peasy because we already know how to do an if statement. So the while statement's just changing it up just a little bit and just repeating that body instead of doing the body of code once. All right, let's do another one. I'm going to stop this thing. It's still running. So I should make sure that my done condition works. I'll test that. I'll put in one sister, and then I'll say done. Is that going to do it? No. I have to actually make it be the uppercase letter D, because that's what we put in our while statement, the uppercase letter D. Could we change that while statement to allow a lowercase also?
Yeah.
What could I put in there?
No, what that? That's the thing I don't know. I think
And, because I'm doing a not equal, so very good. I want it to be an and. It's not equal this, and it's not equal that. Because otherwise we've created one of those conditions that's always true. So while name not equal done and name not equal done with a lowercase d. And of course, there's lots of other ways we could accomplish this, right? We could turn their name to a lowercase string or all uppercase or all sorts of different things. But making this while condition into a logical and condition works too. So let's make sure that takes care of it. I know with my last test that the lowercase done did not end my loop, but the uppercase done did. So this time when I try it, I'll put in a sister or brother, and then I'll put in the lowercase done, and that ends it. So we fixed that little bug where we were having to type that uppercase D. Perfect. Now mine says all changes saved, so make sure your collab document is saying that.
So, if I like to put a sibling name and then put Don, it doesn't end the list.
Here, show us what you mean. Let me okay, take over there and show me what you're talking about. Do you see it, or what's going on?
No, it's not putting done as is in the code.
It's what?
Capitalize the first letter of the word inside code. I'm not doing it now. It's trying to make the word either or.
So I have and.
Yeah.
So like, John, because then doesn't end it after I left the name.
Yeah.
Yeah, I did this before I did and.
So y'all fixed now?
No, not yet. Yeah. What the harsh is doing here. Should be. Should be.
Do you look, if you would look in your while loop, because everybody look at this, please. We need some debuggers here. What's wrong with this code? Why is it outputting the word sister after he types in the word done? Type in different names the first 2 times you run it instead of using the word sister every time, please. Robin. So type 2 names before you type done and make them different, please. You can't test your program. A lot of you guys are doing that. You have to make sure you're using good test data. If you type the same thing over and over, you don't know what you're getting. So what's going on in his program? It's not working properly. Why is that? What's wrong with his input statement in his loop? He's not updating the name variable. Yes, 5,000 points.
Well, wait a minute. So I have name equals input and it still does not line 2.
No, yours would be a different problem.
Okay.
Because I removed mine from mine and it was working, and then it was doing the same thing yours was. And now that I added name equals input, it's running fine.
But that's the thing. I do have name equals input. It still does it.
So does that fix the first problem?
No.
Huh? If it fixes yours, let's stop sharing and let Tim share. Tim, let's see what kind of thing you've done. One thing that is going to be hard for us is, remember, Colab, this notebook, is keeping track of the last value of your name variable. So even if you're done running your program and I open it later, that name variable is still set to whatever you set it to last. It's like the ultimate global variable because of Colab. So that can cause us trouble. What's yours doing, Tim?
So the same thing, like I'll put down name. I'll try to put down done, and it prints done, like instead of actually in done. Oh. Right, where?
So look at your while statement. Can you zoom in on that? Can you control scroll so we can see it a little better?
Yeah.
So look at your while statement. Now, whenever we're making a condition, remember, for an if statement or a while statement, we have to have a left operand, a comparison operator, and a right operand. Then you have the word end, and then you only have one thing. Where's the left operand, the comparison operator, and the right? So I can't just have the word done hanging out there in space.
Is that what you're talking about then?
Right, I gotta have and name not equal.
Done.
Good example. Thanks for showing that one to us, because that's so easy to do. And actually, sometimes Python will let that work. No other programming language will. But sometimes Python can actually kind of make it seem like it's working. So do you guys see what he was missing there? He had if name not equal done and done. And if statements and comparisons don't work that way. We gotta have all 3 parts before the and after the and, if that makes sense. Beautiful. Did that fix it?
Yeah, that fixed it.
So thank you guys. And this is one reason I want you to share like this when you're having trouble, because we could have a lot of other people that are having the same problem, but they are too shy to mention it. Or we could have someone that hasn't had that problem yet, And maybe we can keep them from having that problem. So thanks, you guys. If I'm yelling at you, it's just because I can't hear myself through the mask. Okay, beautiful. So just that really short 4 or 5 lines of code, look at how many things we can learn and see how they work just by experimenting with that. So awesome. Let's move on down. Now we have some numbers that we would like to square. And this one can be confusing just in description. So I can say, I used to have this as an assignment, but since we're going to include it in our collab document, it'll be like it's like an assignment. So what I want you to do is we're going to each work on this together for a few minutes and then come back and check in. So we want the user to enter a starting number, and for every number that they enter, we're just going to write out the square of that number. So that's a little different than what I was thinking about when I first started talking. So everybody, I'm going to set my alarm for about 10 minutes, and let's see how you can do on this one. Your code block is already here. See what you can do with it.
Now we're supposed to revert that to pseudocode.
Maybe it's, you know, the
That doesn't seem to work. See if you can find a website or something that tells you how to do that in Python. Because I obviously don't know how. That doesn't work. You have to search. You find something online for how to do it in Python. I didn't go on the code, but not the square.
I don't, it's not even right. That is right. And then. Right next to it. And then do, instead of the up arrow, do two asterisks.
Oh, that's
This is where it stops.
Yeah.
When I'm looking at the photo stuff, I'm getting rid Oh, everybody's.
And then don't do input numbers so that it doesn't make any sense. Copy what you did during the day. Copy all that on and put it down. Yeah.
Problem solving question. What's the easiest way to square a number?
2 asterisks.
What's the easiest way to square a number?
Multiply by itself.
Multiply it by itself. Come on, you don't need to search for all that stuff. But finding the square function in Python is important. But be a problem solver. It's always a choice. So that'll work. And I looked around, and amazingly enough, a lot of your code looks a lot like mine. So I'm going to stop here and run it again and see if my multiplication is working. That looks better. 25, 7. So finally, I should be able to enter my 0 and have it end. I think I do like having some sort of message at the end, don't you? It seems less abrupt, like we know what's happening, so we know that we got our program done. But that one works really well. I think that you guys were right to find how to do the square function in Python, though. So let's go search Python square a number. And some of these things that I look at, like codify.net, I'm not familiar with that site. Includehelp.com, you know, there's a lot of new sites. But I'm going to look down and I see this one that's in the Python manual. And so they say it is actually 2 asterisks. So some people were trying that and people beside them were saying no, and that's good because that's what we want is a discussion going on. But the 2 asterisks do an exponentiation. So I would have to have number, star, star, and then 2. So it would square the number, take it to the power of 2. And you'll be asked to do like a square root before too long of a number. And in that case, we would have to import the math library to bring up that square root function. So don't forget that math library might be something that you have to pull in if you're not being able to get a math function to work properly. Okay, great. Counter-controlled loops. Most sorry, someone's talking to me. Most of our loops that we've seen so far, we were letting the user control. And those are really easy for us to set up here at first when we're first learning how. A lot of times though, our loops are going to be controlled by data. Like for example, if I want to create an average of somebody's checking account balance for the whole year, I'm going to be looping through 12 months, right? To get all of those different balances. So often our loops are going to be controlled by data like that, like occurrences or how many times people have made deposits or something like that. But we often have some sort of counting going on for that. So just like we saw with our musical chairs game, if we're going to create a loop that's controlled by a counter, we have to make sure we do some things. First of all, our counter is just a variable, just an integer type data variable that we're going to use to keep track of how many times we've run this loop. Now, before we start our loop, we've got to initialize that counter, get it set up properly. Then within our loop, we're going to test that counter. You know, have we processed 12 months yet? If not, process another month. Then within our loop body, we're going to have to update that counter. So let's take a look at this one. In this pseudocode, they start out declaring their counter is an integer named count. Before their loop starts, they set their count to 1. And as long as their counter is less than a number they're asking the user for, they're going to write out the counter and then the value of the counter squared. So if a user said they wanted 5 numbers, then we're going to see the number 1 squared, the number 2 squared, the number 3 squared, the number 4 squared, and the number 5 squared. So within our loop, after we write out that counter, we're going to add to it so that we can keep track of how many times we've executed that loop, because we're going to let them tell us how many times to execute it. Oh, flowchart, I lied. I said that last one was the only one we would create. I lied. Let's make a flowchart of this one. So 10 minutes. You guys are going so fast with flowcharts.
Oh.
Right.
Sorry.
No problem.
Actually, right, like. You just copy except for the
Okay, I see what you're saying. Yeah.
So we always wrap this thing up with this.
I was gonna put it outside. Oh, I didn't know where, but that's why then. Want me to just get it?
Yes, yeah, it's 7 and then 7. What do you got? I had originally. Follow what the Pseudocode is saying, because that's how the line is.
Yeah, we got it.
Now we got our new one. It's supposed to just wherever you're on the queue. Wait, that's weird, because if you go through it, you ask the absolute, like, what you did, whatever, it's just count the pain. Variable. So what's under variable? Sorry. That's what throwing me off. Yeah, I'm not sure. I'm not sure. If that's straight across the count.
Go back to your church.
No, yeah.
Because it's just an entry. Like this week said it.
Yeah, well, let everybody go with that one a little more. That's a tough code.
What you can make
It
it.
is.
No,
Raptor's evil.
we're still confused about
Because
the
Raptor's
count thing.
evil. Well, because Raptor's evil, let's do it in Python. Let's do it in Python. Keep your flowchart, I want it turned in.
Yeah.
But let's do it in Python because Raptor makes you set those while conditions kind of weird. So let's do it in Python. So I'm going to click here on the student activity and add code. Add code, because Python's going to let us do it a little bit the same as the condition is written in our pseudocode. And then I'll let you fight with Raptor on your own. So let's see, this is going to be our count, an integer. To prompt for an integer and count up to it is basically what we're doing in this one. So our user's giving us an integer and we're going to count up to that integer starting at 1. All right. So we have two variables, positive integer and count. So I'm going to set those both to 0. Are you guys going to do this with us? You guys should do this Python program with us and fight with the flowchart later, because that's why we're doing this Python program together, so that you can fight with the flowchart later. I'm making you distract yourself. I know it's hard. You guys have got a problem and you're chewing on it. And I'm making you go someplace else because I want you to chew on it later. All right, we've got our two variables set up. And we're going to prompt for that positive integer. Positive integer equals an integer that we get from an input statement that says, please enter an integer. Now, the next thing we do is set our count to 1. Count equals 1. And then we're going to do our loop. So while our count is less than or equal to the number our user entered. So while our count is less than or equal to our positive integer. And this is the place right here that condition that you have to do backwards if you're doing Python. Or I'm sorry, Raptor. Too many snake words. But if you're doing Raptor, you're going to make that say count greater than positive integer, because that's the only way Raptor will let you set up that loop. But we're doing Python, which will let us do it either way. So we're going to go ahead and keep our loop condition the way it is in our pseudocode. And within our loop now, we're going to print out our counter. Print our count plus a space plus our count times itself for a squared number. Then we're going to add to our counter and it's so hard because I remember in my first programming class when I understood the concept that I could update the value of the variable by using a formula that included the variable itself. That was a big deal to me. And certain concepts like that are things that each of us get stuck on. So it's really hard to know for sure what are things that I should point out. Yes, sir.
And let's look at one asterisk or two. 13.
I just am multiplying it by itself. So, yeah, if I was doing the 2 asterisks, let's do it that way. Because I did this same way the last one. If I was doing the 2 asterisks with the power, I would use 2 there to the power of 2. Perfect. Now, what did they want us to do when our loop was done? That's it. So we didn't need to do anything else. So let's run this. I'm going to enter an integer. Again, my test data, I want to make sure my integer is high enough that I'm going to actually see some results here. I don't want to use like 1. Oops, I got an error. What's it mad at me about? It says I'm trying to print out these integers like they're strings. So that's true. I'm going to have to change this a little bit. If you remember, we saw last time that we could put in str to convert a number to a string so that Python could print it. But that means I'm going to have to do an str cast function on the results of this formula. So we'll see if Python will let us do that. So I'm saying convert count to a string and print it, then add a space, then take count to the power of 2 and convert it to a string to print it. See if it likes that any better. 5. There we go. So we started at 1 and we printed out our counter and our counter squared. And then we added 1 to our counter. So we printed 2 and our 4, and then we added 1 to our counter. We have just enough time, if everybody is this working, to copy this. Let's copy these little lines of code. Actually, I can copy that. And I want to go to that visualize site. Visualize Python. Python tutor. And I'm going to paste my code. Now, the reason I like to use this Python tutor when we're doing a loop is we're going to actually get to see those lines of code get executed over and over. So with this one now, I've got my code in. And if your code is not there, you can just watch. So don't stress about it. It's more important to watch. But I'm going to click Visualize Execution. The processor is sitting at the end of my block comment, ready to finish that comment. I'm going to click Next. It gets ready to set up my positive integer variable. When I click Next, I should see my positive integer variable is now in memory with a value of 0. When I click Next again, I'll see my count variable has joined it. They're both in memory now. Now I'm going to do the input statement to ask for an integer. It's sitting down here basically. I'm going to type my number in, and when I click Submit, it should execute. that line of code. And now we see that our positive integer variable is now equal 5, that number I typed in. Now I'm going to set our count to 1 to initialize it for our loop. And now we're ready to start our loop. Notice for this loop, we had to initialize 2 variables. Now, as I click next, it's going to evaluate our condition. Is count less than or equal to our integer? Yes, it is. So I'm going to execute the print statement in our loop, and then I'm going to update our count variable. And then I'm going to go back to the while statement to reevaluate it. Is our count less than or equal to our positive integer? Yes, it is. So I'm going to print out that count of 2 and then add to my counter. Now I'm going to evaluate my while condition again. Is my count less than or equal to my positive integer? Yes, it is. So I'm going to evaluate or execute my loop body again. I'm going to print out the value of 3 and then add to my counter. Now my counter is at 4, still less than my positive integer. So I'll print it and add to it. Now I'm at 5, still less than or equal. Print it, add to it. Finally, now my counter is 6. My while condition is no longer true. So I'll break out of my loop and be done. And here's all our output up here. So you see how this visualized site can really help you with loops and seeing what's going on with our logic as we go through this. Now we have more in our colab document to do. We're going to get back to this on Wednesday. So your homework, the stuff that you need to do, is the short answers questions, the review questions at the end of the chapter. I've redone them, and instead of just an Excel form, they're now like an Excel quiz. So let me know what kind of terrible things it does to you. If it won't let you save or all those kinds of things, then we'll fix it. Make sure your collab things are saved because we'll finish it next time. Sorry for running right out of time. We use every minute in our class, right? Get out of here. Have a great day, and I'll see you Wednesday.